Learn like a pro.
Have you ever tried to move something that felt way too heavy? Well, it's not magic, it's physics. Today, we're going to pull back the curtain on the amazing power of leverage and show you exactly how you can use it.
Okay, let's start with something super simple, something you do every single day. Ever noticed how pushing a door open is way easier near the handle than it is right up by the hinge? So why is that? Well, the answer unlocks this fundamental rule of physics that's happening all around us all the time.
Yeah, the secret is this kind of invisible law, a law that controls literally everything that spins or rotates. And it all comes down to the power of the pivot.
You see, forces don't just, push and pull in a straight line. When you apply a force to something that has a fixed point, what we call a pivot or a fulcrum, it actually creates a turning effect. And in the world of physics, this turning effect has a special name. We call it a moment.
Okay, so if we have a name for it, that means we can measure it, right? We can actually predict it. So let's break down the super simple but really powerful formula that's behind all of this.
Believe it or not, the formula is crazy simple. It's just moment equals force times distance. That's it. The turning effect is literally just the force you're pushing with, multiplied by how far you are from that pivot point. Sounds easy, right? But there's one little catch you have to know.
And here it is, the big rule. That distance, the d in the formula, it can't just be any old distance. It absolutely has to be measured at a perfect 90-degree angle to the force you're applying. Perpendicular. If it's not a right angle, the math just doesn't work.
So, because of this simple little formula, we get something incredible, something called the force multiplier effect. And this right here is the secret to how using distance can make you feel way, way stronger.
Let's go back to that door again. This is exactly why the handle is all the way at the edge, as far from the hinge as possible. Pushing there gives you the biggest possible distance from the pivot. And that means you can get the door to swing open using way less muscle.
This is just a perfect illustration of what we're talking about. Look, if you push with 10 newtons of force at 4 meters away, you get a 40 newton-meter moment. Fine. But now take that same 10 newtons of force and just double your distance to 8 meters. Boom! The moment doubles to 80. You've literally doubled your turning power, not by pushing harder, but just by moving farther away.
Okay, so we know how to create a moment, and we know how to make it more powerful. But what about which way it spins? Let's check that out.
This part is actually super intuitive. Just think about a clock, right? A moment can either be clockwise, turning things the same way a clock's hands move, or it can be anti-clockwise, turning things the other way. Simple as that.
So what happens if you have more than one force at play? Well, if they're working together, pushing in the same direction, their moments just add up. It's like teamwork. So in this example, you've got a 40 Newton-meter moment and another 50 Newton-meter moment. You just add them together for a big total turning effect of 90.
All right, enough with the theory. Let's get our hands dirty with a real-world example and see how all this stuff actually solves a real problem.
Okay, I want you to imagine this. You're a mechanic, and you've got this super stubborn nut you need to loosen. You know you need to apply a moment of 120 Newton meters to get it to budge. And the spanner you have is pretty long. It's 2.5 meters. So the question is, how hard do you actually have to push on that spanner?
Well, all we have to do is just flip our formula around a little bit. If moment is force times distance, then force must be moment divided by distance. So we just plug in the numbers. We take our target moment, 120, divided by the length of our spanner, 2.5, and there's our answer. You need to apply exactly 48 newtons of force, at that perfect 90-degree angle, of course, and that nut is coming loose.
So, what's the big takeaway from all this? It's that leverage isn't really about being stronger, is it? It's about being smarter. It's about using physics to your advantage. Just by giving yourself a longer lever, you can completely change the game. It kind of makes you think, doesn't it? Where else in your life could a longer lever solve a problem you thought just needed more muscle?